Hello, and welcome to the Gravel Ride podcast, where we go deep on the sport of gravel cycling through in-depth interviews with product designers, event organizers, and athletes who are pioneering the sport. I'm your host, Craig Dalton, a lifelong cyclist who discovered gravel cycling back in 2016 and made all the mistakes you don't need to make. I approach each episode as a beginner to unlock all the knowledge you need to become a great gravel cyclist. This week on the show, I'm handing the microphone back to my co-host, Randall Jacobs, who's got Matt Harvey, founder of Enduro Bearings, on the show. You might have heard us talk about Enduro Bearings a few times in the Dirt episodes as I was deciding and debating what bottom bracket to run on my new custom bike. Well, I decided on the Enduro stainless steel bottom bracket, and I couldn't be happier with the performance thus far. I was happy that Randall volunteered to take a deep dive into bearing technology with Matt, as I think he's got better perspective on the technical elements, and certainly there's no one better to talk about this product than Matt himself. Before we jump in, I need to thank this week's sponsor, Athletic Greens. Athletic Greens is literally a product that I take every day. I discovered Athletic Greens many years ago as I was recovering from my treatment for Hodgkin's lymphoma. I was looking for something that had the vitamins, minerals, and probiotics that I needed to kind of just give me baseline support. After I was through that difficult period of my life, I realized that this was sort of a baseline thing I needed for all my athletic endeavors as well. With one scoop of Athletic Greens, you're absorbing 75 high-quality vitamins, minerals, whole food source superfoods, probiotics, and adaptogens to help you start your day right. It's a special blend of ingredients to support your gut health, your nervous system, your immune system, your energy, your recovery, your focus, and aging. All the things. I encourage you to check it out to see if it's something that might fit for you. To make it easy, Athletic Greens is going to give you a free 1-year supply of immune-supporting vitamin D and 5 free travel packs with your first purchase. All you have to do is visit athleticgreens.com/thegravelride. Again, that's athleticgreens.com/thegravelride to take ownership of your health and pick up the ultimate daily nutritional insurance. With that said, I'm going to hand the microphone over to Randall for his interview with Matt Harvey from Enduro Bearings.
So I cut you off last time we spoke because there are just too many things that I was interested in diving into. And there's the obvious technical aspects of what goes into making a bearing, of the myths about bearings that we might debunk and things like this. But before we dive in, just tell us a little bit about yourself.
Well, I've always been in bicycles ever since I can remember. So I started out as a BMX rat, when I was like 12 or 13. And I started working at a bike shop when I was 13. So I immediately into the mechanical. Well, spraying WD-40 on POJO drivetrains isn't exactly super high-end mechanical things, but that's how it started. So, through there, I worked in bike shops. My business partner now, I met in a bike shop when I was 17. We worked in the same bike shop. I ended up working at Fisher Mountain Bikes. I got an engineering degree. Ended up working at Fisher Mountain Bikes, White Industries, Bianchi Bicycles, starting out in warranty, became a product manager, went to Italy, did their mountain bike line, designed a bunch of road bikes and mountain bikes, full suspension road bike that got ridden in Paris-Roubaix. And that was kind of like when I was looking at bearings, because everybody was using plain bearings or bushings at the time. And the Fisher RS1 with Mert Lawwell that was his design. And one of the first full suspension bikes, I think. Well, not first, but you know what I mean? Like current, more modern production type full suspension bike, I should say. Because suspension bikes go back to, turn of the last century. So that's when I was starting to look at bearings and rolling elements. And that's when they were getting popular. And that guy I worked with at a bike shop when I was 17, he was in the forklift business by then, and he was starting to make bearings for old forklifts. And, we hadn't lost touch, and we were talking, and I started doing drawings for him because he needed CAD drawings for certain things. I was working at Bianchi, and then at one point we decided, hey, this could become a business. So let's start making bearings for forklifts and bicycles. And that's what we still do 30 years later.
Well, and I'm curious, we'll dive into the Enduro Bearing story in a minute, but I want to dive more into that background because there's a few things that I find interesting. One is you have what sounds like a technical understanding of the bike that comes from getting your hands dirty at a young age. I share that experience. And in fact, working on bikes, I think, is a great way for any person to learn how mechanical systems work. But then also you worked in warranty, so you saw what was going wrong. How did your experience working in shops and working in warranty inform your perspective on products?
Yeah, they're all related, right? You can't separate it. Obviously, at one point I realized I needed more school to do what I was thinking about doing. I wanted my boss's job. I wanted to do what he was doing, which was designing bikes, but I didn't have the background or experience, so I went back to school. But yeah, I mean, your hands are in the bikes, you ride bikes, so you get a certain aspect, which is super important, the practical aspect. But then, getting into engineering and so forth, you have to have, the math, the history, and then you get into business, you need business stuff too. But there's a lot of corners you need to go explore to put the whole thing together, I think. And that's what I ended up doing. So at the beginning, it was practical aspect, seat of the pants stuff, because I'm just working on stuff. And that's the way a lot of things happened in the late 80s, early 90s. That's kind of the period I was working on it. But you mentioned warranty. Yeah, I learned a lot in warranty because I saw everything that got broken.
Yeah.
I was at Bianchi Bicycles, and it was the 80s, and Campagnola was king. Shimano was coming with index shifting. But things were being made in Italy or Taiwan or various countries at the time, still a lot in the US. And then there was people were trying to, save money, and then things break. And what happens with heat treating? Why did that thing break? Why was there too much heat treating? Well, I wanted to find out, well, that seems like a good thing. How can there be too much heat treating? So, you learn, you see the broken parts, you see a box of broken pedals, and that's not good. Nobody likes to break a pedal, but you find out like why things get crispy and break. And so I wanted to learn about especially metal, steel, aluminum. At the time it was pre-carbon fiber. But so yeah, I went into back to school and metal shop too. But I was lucky because I also I was going to Taiwan. I was still working for Bianchi. I was going to factories, seeing things, forged, spin welded, all the different ways you make things. So I was getting a practical eyes on learning experience in Taiwan, where all the production was kind of going. I was also going to Italy, and Italy was still making a lot of stuff then. Bianchi was making bikes at the main factory there. I mean, they're getting back to it again, but at the time it was sort of Asia was taking over on a lot of the production. So it was kind of split between, Asia and Italy at the time.
So you were right in there at a number of big transitions in the industry. The advent of the mountain bike, which was very much a US and in particular Bay Area phenomenon. And in fact, I've talked about different tariff codes for mountain bikes. That it was a significant domestic manufacturing operation, and materials were that much more critical because you had this really high stress application that hadn't really been done before. Like those clunkers were not holding up all that well. And then the transition to index shifting, that's another major transition in the industry. That's the reason why Shimano is so dominant today. And also Asian manufacturing, a lot of which was people in the US and European bike industries who were going over and helping to transfer that knowledge and set up that production in what is now Taiwan in particular, some of the best, highest end manufacturing for bikes anywhere.
Exactly.
It's no longer a cost thing, it's a quality thing.
Yeah. And in the beginning, they had the ability to make really high-end stuff, but the knowledge needed to come from the people who were practically riding bikes, because they weren't practically riding bikes. They knew how to make things, but they had to know how to make it. Now, the Taiwanese, it feeds back a lot of times. They do new products that they develop their own new products that are really great. So, but yeah, you're right. Those were the early days of figuring all that stuff out.
Well, and I'd say I definitely see more domain knowledge on the product side in Taiwan than there was in the past. But still, it does seem that the most successful Taiwanese manufacturers are those that have a European or American team that is in the market and kind of on top of the trends. And the trends are still largely driven by those two markets.
Sure, but in Taiwan now, since I started there, it's an entirely new generation that has now grown up in the bike industry, and a lot of them are riders now and stuff.
Yeah.
Back then, nobody was riding mountain bikes who worked at the factories or made stuff or designed stuff. But now you have a lot of people there that are enthusiasts, and I mean, as big an enthusiast as anybody in the world for mountain biking or road bike riding. True. And so it's an entirely new generation. It's great. They've embraced it and they know it and they develop things, materials and design. It's incredible. And at the time, historically, you go back. So Italy and France were the huge innovators back when, right? They came out, derailleur, it's a French word, and the Italians didn't embrace it immediately. They had other ideas. But at the time when I went there, it was an interesting time because Italy was king, but not quite becoming, they didn't catch the mountain bike wave. They were looking at Specialized and these innovators at the time, Fisher, Ritchie, all the people that were innovating, and they couldn't keep up. They didn't quite, because they were a mature market and not looking at that. So I was the American brought in to be the eyes and practicality of that part, which I was, it was a little frustrating because you couldn't quite keep up. And then the name Bianchi and mountain bikes at the time, no, people are going to buy a Fisher or a Ritchie or something, or an Ibis, So that was a uphill battle. And that's why European brands or Trek, they bought mountain bike brands, Gary Fisher brand, and to sell it because they were known as a road bike company. And that's what people were doing at the time. So it wasn't always necessarily not great ideas at these companies. It was marketing too. You have to have it all.
It's interesting. Like you think about Campagnolo, which was really great and major player. And they're still significant, but substantially diminished vis-a-vis Shimano and SRAM.
Sure.
The two, arguably we have a duopoly in our industry and it's those two. And Campagnolo makes some good stuff, but they didn't come out with hydraulic disc brakes until much later.
Right.
And even then, I think they work with Magura on that. I don't know if that's in-house now. Their more recent offerings with the eCar group, I think, are innovative, and I'd like to see them contest for more spec because the industry does benefit from competition. But yeah, it's interesting to hear your perspective on how the industry has evolved. What year did you enter? When were you working in those shops?
So first bike shop was 1976. And then I worked in shops until about 81, and I ended up starting at Bianchi Warranty in the 82 maybe through 80, 85. And then I went over to Fisher. I went back to school. I simultaneously worked at Fisher and was in school. And then I started moonlighting at White Industries because Doug White was making titanium spindles for Fisher. So that's how I made the connection there. And I would go over to his shop. They were pretty close by. There was a lot of people around then. Dave Garut, DKG, he still makes seat clamps. He was making motorcycle stuff. There was Salsa. Everybody was kind of in the same area and everything was happening up in Marin then. So, I talked to a lot of Peter Johnson and all these people that were making stuff. And so I went back when I finished school. It just coincided with Bianchi needing a product manager for mountain bikes specifically. So I got rehired at Bianchi as product manager. And then it was a lot of whirlwind, once a month to Taiwan, once every 2 months to Italy. I was on the plane all the time doing a lot of stuff and developed 2 mountain bikes there. And that was a transition of going from bushings to rolling elements, bearings, and seeing that, the bearings weren't hacking it. I wanted bearings because they're faster, than bushings. Bushings are slow in a suspension linkage. And if you're going over high, water bars or high frequency stuff, they're just too slow. Bushings can't react. So rolling elements work better, but they were wearing out fast. So it was trying to figure out how to do better ones. And then that was kind of my transition into bearings when my friend from the bike shop he was down at his shop in Emeryville making much larger bearings, like 5-6 inch diameter bearings for forklifts. But they were max type, which we use in suspension bearings. I go, oh, that's a cool idea. Forklifts use these full complement bearings full of balls. And why don't we do that for mountain bikes, but just make a micro version. And that was the beginning of trying to make bearings for suspension bikes, and kind of the beginning of it.
So let's talk about that. I remember a lot of it was cup and cone for bearings. I remember bushings and mountain bike linkages. And then cartridge bearings, when did those come to the fore? And is that where you started, or were you doing loose ball initially?
No, it was cartridge bearings, but yeah, you're right too. Like cup and cone were often max type bearings, as you say, no retainer, but
which is to say the balls are rubbing up against each other, spinning in opposite directions. So there's a high degree of friction between those two surfaces of the balls versus having a retainer with a lower friction coefficient separating them.
That's true. But surprisingly, the friction between the balls is actually extremely low, believe it or not. I mean, theoretically, you would imagine that there is, but the balls are so smooth, and I've studied this a little bit. There's very little friction from the balls rubbing against each other without a retainer. It is a little bit better with a retainer, but it's almost immeasurable. It's really small coefficient of friction between the two.
Oh, that's super interesting. Are there applications where you would not want a retainer then?
Usually bearings run smoother with a retainer. The thing about max bearings is you have to get the balls in there. So there's a side hole, if you will, to feed the balls into their slots.
Okay. And that makes sense.
It gets into the ball path, and that creates more friction than the balls rubbing against each other, especially in an axial, like if they get off center and they rub against that fill slot. So that's why they're really good for pivot bearings, not really recommended for hub bearings or bottom bracket bearings for that matter.
Yeah, because you have those non-radial loads that are being applied to them.
Right. Now, the old ones...
I just want to state, we did promise a properly nerdy podcast for this, so we're going to get into the weeds. I'm loving this. I hope that our listeners will as well. There's a lot that goes into bearings that we kind of take for granted.
Sorry, I can go into the weeds pretty quick.
That's the point. That's the point. This is as much for me as it is the audience. So let's go into the weeds. So you have this. I was actually going to ask how you get the bearings in there in the first place. So you have a single location where there's a notch, and then you have this retainer that makes sure that the bearings never track into that notch.
Well, yeah. So in a retainer bearing, you can assemble the bearing without a fill slot. So you put in all the balls on one side, and it kind of, well, I'm not going to demonstrate it here, but they all go in they're all on one side of the lower race, and you kind of snap it together so there's no fill slot on a retainer bearing. And there's only so many balls you can get in there because of that design. And that was developed in Germany in the late 1800s. And then max bearings, those were the first ones actually in aorless hubs going back to 1860, 1870s. And they're angular contact. Aorless hubs.
That's I think Bontrager had a line of wheels called aorless. Is that the same?
Yeah, I think they revived the name, but
got it.
Yeah, it's it's a really old hub name, and developed for bicycles. Like the first precision bearings or interchangeable part bearings were developed for early bicycles, rolling elements, that standardized rolling elements.
Were they even bicycles at that point, or were they like velocipedes or some
velocipedes?
Of these, like so
safety bicycle was until 1885. So, but same bearings were used in those, and bone shakers, or the various things that you saw developed, 3 wheels and 4 wheels and so forth back then.
And this term velocipede and safety bicycle, for those who don't know the history of the evolution of the bicycle, can you talk a little bit about that?
Yeah, so I think velocipede is a thing that rolls by human locomotion, whereas safety bicycle, penny farthing is the large wheel up front because it was pre-chain gearing, and that's how you got your gearing, was to use a really big wheel in the front, or
Yeah.
medium, various size wheels.
Yep.
The race bikes had a huge wheel, extremely dangerous. And then they called it the safety bicycle with two wheels the same size, chain drive, because it was much safer than a bone shaker or penny farthing with the big wheel, because the crashes on those were horrendous.
Sure. You're starting from a high point, and then if you hit anything, you're going lawn dart, but then still fixed gear. And then you had to have ratchet mechanisms or some sort of free hub or free wheel. And all these things that we take for granted, they had to be invented and evolved, and materials had to be there, and the production tolerances had to be there for all of this to exist.
That's right. It was pretty quick how the development of the bicycle, all the things that became developed came in quick succession. It's amazing how early things were invented that we see as quite advanced. In fact, I was just looking at something recently because there's a 2-speed rear hub that has become pretty popular in the industry, classified in the first 2-speed rear hub was actually like 1896. That's how far back stuff goes.
What was the company behind that?
Actually, it was called, believe it or not, the name of it was so early, they just called it the Hub. That was the name of the company. And I forget the guy who developed it, but he called it the Hub, and it was extremely popular, 2-speed rear hub. And then there was like 5 companies within 2 years making them back then.
Got it.
We are getting into the weeds here, but it all comes together. It makes sense because people are always looking for, right now it's a front derailleur thing. With full suspension bikes, it's hard to put a front derailleur on the bike. And, so the 2-speed hub, here we have it again, because it solves a problem. But it's interesting to know that it was developed 100 years or over 100 years ago too.
Sure. Yeah. Yeah. And it's also like the solution that you had in the bearing space, it had a context, right? It's another one of these enabling technologies that had to be put in there to have, you look at something like the Delta suspension design that Dave Weigel came up with for Evil, and just the number of bearings in there. And imagine having that with a bunch of bushings that have a high static friction and so on. It just doesn't work. Never mind the high rolling efficiency of our wheels and bottom brackets and all these things. So let's go back to bearings. You alluded to how Enduro got started and you were doing forklift bearings. So let's continue on that vein.
All right. So we were making bearings for forklifts that you couldn't get anymore because forklifts last. They're electric vehicles, or, you can put a new engine on them. So the car of the forklift keeps going. Or the truck. So we were making specifically the bearings that go up and down in the mast that hold the forks. So those have to be, they carry extremely high loads and they don't spin very fast. They're max bearings. And that's
what defines a max bearing?
Maximum fill of balls. So not a retainer bearing. You can if you take the retainer out and just fill it full of balls, maximum fill, you can put about 35% more balls into the bearing. And then
that's significant. Okay.
Yeah, your load capacity increases by that amount, 35%.
So you can either have a bigger bearing, or you can have one of these max bearings to fit the same amount of load capacity into a smaller form factor.
Exactly. And as long as the rolling element isn't spinning really fast, like, it's not an electric motor going 10,000 RPM. It's going maybe, 20 or 80 RPM, pretty slow. Even on a bicycle, cranks and wheels, they're hundreds of RPM, not thousands. So, in a suspension pivot, it's just swiveling back and forth, maybe 15 degrees. So max bearing makes sense because it's not spinning. You're not looking at a lot of friction from the fill slot or whatever. So we were making those forklift bearings, and White Industries was actually making them for us up in Novato, those early ones. We made some at the shop. We were turning at the shop, but when we got into larger numbers, White Industries was doing it. And so I was working with them, and then we ended up making some hub bearings, which are retainer bearings, which for hubs need to have higher precision to spin smoothly, because in a back hub, you have 4 or 5 bearings that you're stacking up, and you need a higher level of precision. That's why we do ABEC 5 bearings at Enduro for hubs specifically, because you need a higher level of tolerance. Now, ABEC ratings are significant in that they give you a level of the precision. However, all of the ABEC parameters are not really applicable to bicycle application because it's really a lot about noise ratings and spinning at 10, 20,000 RPM, which bicycle bearings never do. So we do ABEC rated bearings for the ID, OD width tolerance to make the alignment correct, but we do a very deep groove to take higher loads than most high spinning bearings.
Got it. That makes sense. So you have a bigger surface area where the bearings are contacting those races, and thus you have less deformation of the balls, less deformation of those races as as it's spinning and that load is, coming on and off of each ball.
Right. And so a lot of high ABEC rated bearings may not be good for bicycles because to reach the noise level testing, it's easier to make a high ABEC rated bearing with shallower grooves and less surface contact. But that's not good for a bicycle because you have pretty high axial loads. And everybody who makes hubs and bicycle components in general, they're always trying to save weight. So they try and use the lightest weight bearings possible. So you need that bearing to be as robust as possible to resist the loads of the axial loads, radial loads that small bearing has to put up with.
And just to clarify terms for those in the audience who don't have an engineering background, radial loads being those in plane with the bearings. So in the same plane as the bearings. So if it's a wheel, it's like a load that's coming straight up perpendicular to the ground through the center of the bearing essentially, versus an axial load would be like a twisting load on that same bearing. So if you have a lateral force on that wheel or something like that, which you can have, presumably you have somewhat significant axial loads especially in like mountain bike linkages and rear wheels and things like that.
Oh yeah, or even road wheels, like a rear hub when you're going up a hill, like a really strong rider out of the saddle, going back and forth. There's significant axial loads and twisting between the cassette mechanism, where the sprockets are, and the hub shell. You're literally trying to pull the thing apart because it's not a motor running it on a chain, like sitting stationary, like a generator motor or something. The human doesn't put out constant power. So that's why you see elliptical sprockets and stuff. But you're basically putting on as you're going up a steep hill, let's say, you're twisting everything apart. So there's high axial loads on the rear bearings and even the front bearing. When you're sprinting, the front wheel bearing, it's moving side to side when people are throwing their bike. And you have now disc brakes too, which puts on unequal loads because it's one side of the hub onto the bearing. So you're pulling the bearings over again with disc brakes. And that's brought a whole new, well, for me, I like it because it's a challenge, but that's another new challenge of a conundrum of problems to address with front wheel loading, because front wheels were just mostly along for the ride with rim brakes, but with disc brakes, you gotta look at it closer. They're asymmetric forces on the front wheel now too, uneven forces.
Yeah. And it's on the hub. It's also on the fork itself. And fork legs had to be redesigned. A primary driver of the creation and adoption of through axles was also because the torque loads were so great. And in fact, if that quick release was not tightened fully, you could actually have a wheel eject itself. So yeah, just massive forces in those areas that people don't really consider when they throw on a 1,300 gram wheel set and say, okay, this is going to support my entire weight and keep me safe at 30 miles an hour on a steep mountainous descent.
Exactly. And a lot of times the bearings are, even by the designers, surprisingly, sometimes they're the last thing thought about. And they say, oh, we need a bearing to fit in this, it's got to fit under the disc and over the through axle. And it becomes extremely thin. And then you got to look at other ways to make a solution for that so it holds up and doesn't burn out. I mean, early in disc brakes, that you'd see hubs that the disc would get so hot you could burn out the disc side bearing in one downhill run, for instance.
Oh wow!
And some riders
I didn't realize that.
Oh yeah, and some riders were buying like full tubes of the disc side front wheel bearings for certain hubs because they would knock it out after every run and put a new bearing in. It got so hot it would like boil the grease out of it and just toast the thing. It would practically set the weeds on fire, because it got so hot. I mean, the disc brakes have improved in cooling and some other things, and people have gotten smarter about the hub bearings on that side. But like about 8 years ago, we were selling a lot of certain sizes of bearings for downhill guys.
Well, and disc diameters have gotten much bigger. You have aluminum spiders with venting that can help to shed some of that, transfer it to the air, versus early disc brakes were, I mean, a lot of it was 140 millimeters?
Yeah,
like
small ones.
Not a lot of...
There was no disc when we started with that RS1 with Mert Lawwell. We needed a disc brake. There were none around. We used to fill disc brake from back then. That was all fiber disc. I don't know if you remember that one, but there weren't any discs that and they faded miserably. That was really hard thing to slow that bike down.
Yeah. Again, I can't impress upon our audience enough of just how good we have it right now in terms of how you can have an extraordinarily lightweight braking system that will stop you plus your bike plus whatever gear you have reliably and consistently for long periods of time. And everything just works. And it's actually, I remember my first bikes, I'm only turning 40. My first bikes didn't just work. There was a lot of service. There was a lot of parts failures and so on. And now things just seem to be engineered and manufactured to a much higher standard, such that it's increasingly surprising when things don't just work. And bearings are a big part of that.
And so, if you don't mind, there's one development that I worked on from a long time ago. I had heard about this metal that Airbus had developed, and for making bearings in the planes. And I read about it, and I immediately wanted it. And there's only a couple foundries that make this particular steel in the world, but I knew it was going to be perfect for ceramic bearings. And but it was frustrating because the amount of steel that I needed, even though it was a lot of money for me, they would never be interested in. I got my business partner speaks German. He called the foundry in Germany, and they basically hung up on him, or they didn't hang up on him, but I was like, yeah, thanks, kid, see you later. And I was at a show, and I met this guy who, people trying to sell me metal all the time because we make bearings, but this guy, I heard the word nitrogen steel, and I said, wait a minute, you can get nitrogen steel. And he's like, oh yeah, I represent the company. So long and short of the story is he's a mountain biker who worked for the foundry in France. There's only 2 foundries. So he got me in there and was able to get me some steel. And so we've been making XD15 bearings now for over 10 years, I think maybe 12 or something. But that material, because ceramic bearings, when you think about ceramic bearings, they're kind of fragile, right? They're really great because they do spin really well, because you have a super hard ball. It's 7 times harder than steel. It won't flex or push out of the way, deform. But it wears the races out if there's no grease, or, they can rust and all these things. And here's this material XD15. It won't rust. It won't corrode. And you can run a ceramic ball in it with dirt, whatever you want, and it won't wear out.
It'll just pulverize it, whatever gets in there.
Or it burnishes the races. It'll like polish. And so you don't get galling or pitting. So what usually happens with a bearing when it wears out, it'll just, you get dirt or no grease in there. And what happens is you get a pothole, essentially, if you're in the race. And it's a little pit in the race. And then as the ball rolls over that, like a car running over a pothole, it gets bigger and bigger until you feel that it's rough. So that's what happens when a bearing wears out. Well, that doesn't happen with XD15, nor does it corrode. So me and this guy, we're still buddies, and he still rides his mountain bikes, and he gets me the steel. Still, we're still friends, but the bike industry is so small. We're probably 20 minutes or not even 10 minutes of production out of this foundry for all we buy in a year, because Airbus soaks that stuff up by it's just aviation uses so much more material than, any sports industry thing. So I'm just lucky to be able to get it, but it's an interesting material to work with. We have to get rod. We can't get tubing. You got to drill it. There's a lot of, it's hard to make these bearings, but I'm kind of proud of it. I mean, it's my favorite thing that we make because it answers the question when somebody calls and says, I want something to put in my bike, and then I never want to work on it again, which is kind of my goal too, because I never have time to work on my bike. And it's just like, I want to, you can put these bearings in your bike and never think about them again. So that's why I like them.
Well, and this is a great segue into a topic that I think a number of our more performance or competition oriented listeners will be curious about, which is the ceramic bearing landscape. Right? There are a few options out there. Maybe they're included on a very premium wheel set. Maybe it's some bearing kit that you can press into your existing hubs. But the perception that these are better or even necessarily faster or more efficient is not really backed up. And there's a phenomenon where, you end up, and I made this mistake. I bought, ceramic bearings early on, trying to get every little edge. And the science simply says that, well, it may give you a slight, maybe imperceptible benefit for a few hundred miles. And then the performance is going to degrade rather quickly because a significant part of that performance benefit has less to do with the bearing and more to do with, say, the thinner grease that's being used or the lighter seals that are being used. And then you have contamination, you have the galling and pitting that you just described and so on. So maybe help us to understand the ceramic bearing landscape generally and what's true and not true about ceramic bearings. How do you make a good one? How do you make a bad one?
Right. Well, what you just said is all true. Friction in bearings has more to do usually with the seals and the grease. At first, grease dissipates, and, after you've ridden it a couple of rides, it dissipates and it's less of a factor. But brand new out of the box, there's some grease, not friction, but resistance.
To the viscosity of the grease, the thicker the grease, the more resistance it applies. It's simply just within it, the friction of the material within itself.
Exactly. And, first of all, the reason you don't see a lot of data about actual test data about what that is because it's really small and hard to measure what that wattage difference is. So your drivetrain is about 7 watts of suck, or if you will, or and 5 of the watts are the chain, because it's basically a chain is 110 plain bearings rolling around on your sprockets. So that's
plain bearings, meaning not having a ball bearing. It's just a metal on metal interface.
Rolling element. So it's a steel ring that rolls over your chain rings, and their chain is extremely efficient. It's great. That's why we use them. But so that leaves 2 watts for all the bearings in your bike. So if you do the math, there's at least 12 bearings.
So 2 in the front wheel, 4 or 5 in the rear wheel, 2 in the bottom bracket, and then 1 each of the pulleys. Oh, and the pedals. Yeah, and the pedals. Yep. Can't forget that. Usually it's a cartridge ball bearing and then maybe a needle bearing on the outside because it has to fit in that really tight form factor.
Exactly.
So 2 watts for all of that.
Yeah, so you're talking under a watt. It's per bearing. So it's really hard to measure because not very many people have equipment that can measure under a watt, and even a bad bearing is still under a watt. We're talking 0.2, 0.25 watts per bearing, something like that. So there are some efficiencies of ceramic. What that is, I'll let you leave it to your imagination, but it's not like full watts, let's say.
Yeah.
It's, and my interest, so ceramic bearings in general are always best, as you just pointed out, right out of the box. And then they go downhill from, if you will, from there, they deteriorate and you have to keep up with servicing. XD15, the reason I really like it, it's more of a longevity story than a wattage story. Well, it is a wattage story because they actually get better over time. The balls burnish the races and they get smoother. But what's nice about them is they don't wear out. And if you don't want to service them, you don't have to. So you can never open them up and put grease on them. You can just keep riding them and they won't get loose or they won't get rough. They might get rough when you get some dirt in them, but the dirt will dissipate, get ground up or come out, and they're fine again. So that's what I like about them. If you're talking about wattage, they're a little bit better, but it's almost immeasurable. So right now we're doing some wattage testing on bearings, but how we're able to do it and see the differences is we have to amplify the tests. So we're overstraining the bearings so that we get out of one bearing, we can get 10 watts. Actually, it's less than that, 7 watts of resistance. But we're overstraining this bearing, and we'll publish this next year. You'll see it, but in a way to amplify the results. And then we do comparison tests.
And there's some assumptions that need to be made as to whether the relationship between the load applied and the change in wattage, is it linear? Is it exponential? That's interesting. And I appreciate how transparent you are about this, because it's a question that we looked into when we were developing our wheel line, which use your bearings, by the way.
Oh, great.
Thank you. I had a great conversation. No, thank you. One, you make a great bearing, and two, you had product available when we needed it, which at that time was a big challenge. I had a long conversation with one of your either support people or engineers. I suspect if it was a support person, they have an engineering background because they really knew their stuff, and talked about the different ceramic options. And the only one that really resonated with me as a potential offering in the future was this XD15 because of the purported benefits you cite. But listeners should not lose sight of the fact that this is a marginal gain at best in terms of performance. A lot of it is probably coming from the ability to use less restrictive seals and a lighter lubricant in there, as opposed to the bearings themselves. But the benefit is there. But unless you're, either riding to the ends of the earth for years on end and want something ultra durable, or you are a high level competitive athlete with a sponsorship and a team car and a mechanic who works on your stuff, ceramic bearings, it's not the lowest lying fruit in terms of improving your performance. But at the bleeding edge, if you're going to do it, you would want to do it with something that maintains its performance advantage over time. And that is not true of a lot of ceramic bearings out there. And in fact, quite a few of them are manufactured to a standard such that they're actually worse out of the box than even a traditional steel bearing. So maybe...
Yeah, it depends on, so there's a lot of different balls out there. There's very few factories in the world that make really good ceramic balls. Saint-Gobain or Panasonic or Toshiba in Japan. And then there's a lot of balls you don't want to put in there that are worse than steel balls. So, that's another reason for the price, because if they're really cheap, ceramic bearings, they're probably really cheap for a reason, because I know what the price of the good balls are, because we buy them all the time. But that's the first thing, is good ceramic balls. You do on if you use, so what we're talking about, the other steel, so there's XD15 steel that we've been talking about, which is called a nitrogen stainless steel. And the other steel that is used almost across the board is called 52-100 chromium steel. So that's that's the steel that everybody pretty much uses in ceramic bearings. And it can rust. It's extremely hard to get it up to like 60 Rockwell, which is really hard. That's why that's why factories use it for bearings. It's industry standard. But with a ceramic ball, it can wear it out unless you keep up with the maintenance. So that means when the grease is gone, you probably got about 2 weeks left before that bearing. If you keep riding, if you're riding a couple 100 miles a week, you probably got a couple weeks left, and then it's going to be rough. So you got to keep up with cleaning it and greasing it. And, if you clean them and grease them, ceramic bearings, on a regular basis, they last a long time and they work. But that's the reality of ceramic bearings with that steel.
I look forward to getting some data sets from you, because the XD15s are actually something that I'm quite interested in for future offering for us. They're not cheap, but if you actually want to have the benefits both upfront and over time, it is what it costs. Otherwise, unless you have a mechanic constantly taking care of your bearings, popping seals and repacking grease and so on, you're better off with a high quality steel bearing.
Yeah, I think so. But, I tell people the story, and they still buy the regular ceramic bearings all the time, because I just can't. I come from an engineering background, not marketing, so I just kind of tell it like it is. I'll get them anyway. And they put them in. said, you know what, you're wrong. They roll better. I can feel it. But
Yeah.
that's, I get it all the time. And it's like, well, it's okay. It's, there is a lot of in the mind, especially with bike racers, it is a psychological thing, like if you're on the best bike you think you have, then you probably are faster too.
Yeah, there's that. I'll tell you too, though, I was friends with a European pro who I was talking about because I was just coming up and I was never at his level, but asking, does it matter all that much what you're riding and so on? He's like, honestly, yeah, I want to win. I want to have the best equipment, but there's a lot of parity between what's out there. And if you pay me enough, I'll ride a shopping cart.
Yeah. If you're strong, you're strong. You're going to win the race.
Yeah.
No, that's very true. I agree.
Well, I think ceramic bearings, they have a lot of bling factor. So if you say that your product has ceramic bearings in there, it doesn't really matter if the bearings are better than a non-ceramic bearing. It just matters that you can say ceramic bearings. And now you just marked your product. In the case of a wheel set, it's anywhere from several hundred to 1,000 or more that you're able to mark that product up because it is perceived as having the best of the best, even if it's not necessarily the case.
Yeah, and in the case of XD15, so the ceramic ball is perfect for that material. Number one, when we started, there were no XD15 balls available, so you would have to use chromium steel or 440C stainless balls, which is another bearing steel that's out there. But the problem with 440C or an unmatched steel ball in XD15 is it micro welds, and then you do have problems. So with micro weld is the ball actually under pressure welds itself to the race in certain situations. So for XD15, you have to run ceramic balls. And the benefits also are that they won't corrode like the XD15 material. So they're kind of made for each other in this instance.
It's interesting. It reminds me of a phenomenon with the doors of the space station where they were finding that the door could seal shut because you had raw aluminum surfaces that had no oxidization on them. And so it basically would bond and weld in that vacuum.
Oh my God. And then right when Alien shows up, you can't jettison out of your craft.
Yeah. So thank you for this dive on ceramics. I find it really fascinating, and it was no less so when I was talking to one of your teammates. So let's talk about the bearings that most of us are riding, which is a steel bearing, typically a stainless steel bearing. What goes into a good bearing for all the different applications on the bicycle? So this is everything from headsets to bottom brackets and radial bearings versus angular contact bearings and so on. What makes the kind of the best bearing for each one of those applications?
So it's a really good question. Let's just go with the most common bearings. The most common bearing in the bike industry is this number 6902. And so that's an industry standard of a bearing. And just briefly, 6902, the 6 refers to radial, 9 is the series, and then 02 is the internal diameter. That's, if anybody's interested, that's how that works. So 6902 though, so it gives you some specificity about the bearing because that gives you the ID, the OD, and the width. However, what's inside the bearing can vary greatly. You can have different size balls, you can have different depth. So there's no standard on the 6902 as to what it looks like on the inside, but that's the important part, right? So you can buy a 6902 that works in a printing machine. It's very common in big printers, and it's going back and forth. Or you can put a 6902 in a turbocharger, and now it's going 50,000 RPM. And now you can put it in a hub, and it's going 200 RPM, and it has a lot of axial loads that we talked about earlier. So you'd have a different 6902, even though it's a standard bearing in each of those applications. For instance, if you put a bunch of grease, like we do 85% grease fill in a bicycle 6902, because it's only going 200 RPM and you want it full of grease. If you put that in a turbocharger bearing going 40,000 RPM, that grease is going to fly out and set the car on fire.
I was going to say, I was expecting a flammable situation.
Yeah. So for a bicycle application, I started by designing the inside of the bearing for the bicycle application. So number one, it's got the biggest ball possible because that's your biggest load bearing capability, is to start with that.
Okay.
Second, you use the deepest grooves possible that you can design around, because some of them are shallow grooves and you have loads, side to side loads, axial loads, and you need to support the ball. Once the ball rolls past the groove and it's on the edge, you're either like doing some damage or it's not supporting how it can. So deepest grooves, largest balls, and then we look at the seals and we do groove type seals. A lot of, so 2RS, you use 6902 2RS. 2RS literally means two rubber seals. That's, but it doesn't tell you what kind of seal. So we do these seals called LLB and LLU. And those are, we actually machine a groove into the seal at that point, and there's two lips that run inside that groove and
machine into the races, right?
Yeah,
Where the seal is interfacing with the race.
Exactly. And there's always an external groove to hold the seal, but on the ID, there's often just a flat surface that one lip, a 2RS seal, just rubs against. But it's not very, and sometimes they don't even make contact on cheaper bearings. You know, you can hold them up to the light and see the light shine through.
Oh, wow.
It's like, well, it's not even making contact.
Which means that all sorts of grime and dirt and dust and water is getting in there in a bike application.
Right. And so like our dual lip LLB LOUs, one lip keeps the grease in, and then the other is kind of a sweeper seal that keeps the dust out from the outside. And then in between the seals, you get some, when you start turning it, the reason for the full grease fill is some grease comes out, and that makes an extra grease seal, if you will, on the ID of the bearing. So that helps
inner diameter of the bearing.
Exactly, and helps keep the moisture from crawling in. Or
the seal is static relative to the outer race, but the inner race is turning, presumably because it's a smaller surface area, so you have less friction.
Exactly,
by doing it that way.
Engineering mind there. Yeah, so less friction on the ID.
Physics,
that's why they do it.
Physics nerd. Yeah.
No, that's good. Yeah. And so, and the grease, so that's the dynamic lip on the inside, and the grease, you get kind of a grease barrier there. So on Enduro bearings, you'll have some grease come out, and that's a good thing, because grease is another barrier that catches dust and holds it back from getting inside. So that's the basics of how we design the bearing. Of course, you have to start out with good balls, good material, good steel. It's like making bread or, food. You got to start out with good ingredients to have good end results.
And when you say good ingredients, you're talking high precision in the formulation, the right heat treatments, really tight tolerances, high hardness that is also consistent across the entire material. And there's all sorts of technologies that make that possible too. There's a lot that goes into a bearing, even if it looks the same as a cheap bearing.
Exactly. You got to get the steel from a good foundry. It's got to be clean without pollutants in it. And we're lucky because we have the industrial side that we buy a lot of steel every year. And so we're able to buy from the bigger foundries that supply the big boys, the big bearing companies, because we're a little teeny bearing company, in the universe of bearing companies, but very niche area, but we do enough that we can buy good steel because of both sides. But so you start out with really good 52-100 or 440C or XD15. Obviously, you have to start out with really good steel and good steel balls, and then heat treatment. So for XD15, that stuff has to be heat treated on ceramic tables you have to pull a atmosphere. It's of gas. So to do it properly, it's not just in what
pull an atmosphere of gas. Do you mean like you're doing this in a vacuum?
In an inert gas to keep it stable.
So you don't have oxidization or something like this.
We do the same with 440C. And then we do cryogenic treatment as well. So you bring it down to almost absolute zero, and that normalizes the steel so it lasts longer. So these are the things people don't really know about. With 440C and XD15, it's similar heat treatment. It's not exactly the same, but it does go from those ceramic table induction heat treatment to cryogenic treatment. And other bearings can be heat treated in like a gas environment without that atmosphere and so forth. That's why they cost less. But, there's different processes for different levels of bearings. They're not just
Mhm.
all going through the same process.
Yeah. And it's the sort of stuff where even if you don't have the technical expertise to be able to understand the nuances of this conversation that we've just had, I think the thing to really make clear is that, again, two things that look very similar can have very, very different properties in terms of how they perform out the gate and how they perform over time. And to make a quality product, well, when you buy a product, you're essentially trusting that company and that product manager and the decision makers on that product to really focus on those details. And it's not just the company, it's not just the product manager, it's also the team at all the vendors.
Yeah, there's a lot of things, I obviously go deep here. We do a lot of things that people just don't know about, because you buy it and you see it and it's like, well, what's the difference between this one and this other one? And we do, for the suspension bearings, the pivot bearings, we do a black oxide treatment. And when we do it, it turns the bearing black, and people like it because it looks cool, but people like black things. And
Yeah.
there is an advantage to it, because it actually does a second heat treatment to the metal besides making it corrosion resistant. But we got to take those and we got to grind it off where the ball rolls, because you can't have the black oxide treatment where the ball rolls. Well, there's similar products out there, and they're black and they're max bearings, but it's almost like a paint that they do, or sometimes it's black oxide
Yeah.
treatment.
Yeah.
But then they don't take it off the inside of where the balls roll. And what happens
Yep.
is, if you do black oxide treatment and you leave it on where the balls roll, that stuff rubs off, mixes with the grease, and makes a nice paste that wears the bearing out faster than if you just didn't do it at all.
Yeah. And there's so much of that in our industry. I think that's something across the board, but we are a highly technical industry. The bicycle is a highly technical product. And there's so much to know in order to do things right that you can't really expect a rider to know all of this stuff. And so they're like, oh, ceramic, great. Oh, this black coating. Well, it looks like the other one and it's cheaper. Okay, great. I have the latest and greatest. But I've seen so many examples across the industry, including on projects that I have been involved with and didn't have authority over, where decisions are made purely for marketing purposes, purely to get you to think that it's a better thing and to spend more money on something that oftentimes, at best, it's neutral. And oftentimes it actually makes the bike worse in ways that you will experience over its lifetime.
Yeah. And it's hard to get, it's hard to get people interested in, say, bearings sometimes, because you don't see them in the bikes now. They're all buried, like, new carbon bikes. There's bearings inside that thing. There's nothing. It used to be you could see a headset. Hey,
we used to press them directly into the carbon frame, because that was a good idea. There's one other thing that I wanted to call out, which I thought was interesting when I was looking through your bearing catalog, which is using different seals on one side of the bearing versus the other. And because the risk of contamination is always much greater on the exterior facing seal, but the one on the inside, well, there's not much to contaminate there. For example, facing the inside of the hub. So you can run a seal that keeps the grease in, but doesn't need to be as tight for water ingress and thus can be lower friction. So even like those little micro optimizations matter.
Yeah. And so, if you roll back like 10 or 15 years ago, everybody wanted bearings in their wheels to spin like a metal roller skate wheel, where you spin it and it won't stop. Or you see those videos of people doing that.
The YouTube videos. Look at how efficient my bike is, because when there's no rider on it and it's up on a stand, it just spins for a long time. And somehow that is a good proxy for how it performs in the wild.
Yeah. And so if you take the seals out and put sewing machine oil in there, you can get it to spin like crazy. Old track bikes used to do that. They do that. But it's on a track, but if you're riding out in the rain and stuff. So we used to do, getting back to your question, we used to do just LLB seals both sides on the ABEC 5 bearings, which was real popular wheel bearing. And, in certain environments, especially like Vancouver, wet environments, Vancouver, different places where there's a lot more rain, people say, hey, the grease is getting washed out too quick. We're getting dirt ingression. So we always had LLU seals, but LLU, if you use industry standard LLU seal, it's really tight. And
LLB versus LLU, LLU is the tighter
medium contact.
Okay. Yep.
or
Versus the LLB, which is
light contact.
light contact. Okay.
LLB light contact, but LLU in the industry is pretty tight contact. So we make it medium contact. So we re-engineered LLU for bicycle industry basically. So ours is medium contact. So it's an acceptable amount of seal friction. If you do it too much, people just don't like the way their wheels spin. It's really sealed, right? But it just, you spin it and it goes once around and stops. Like if you had a really tight seal in there. So there's compromises.
It's kind of like you want a bike that lasts forever, but are you willing to add that half pound of weight across the entire bike to make it more durable? That's a half pound that I'll add every day. But if you want to be in the magazine listed at some headline weight, well, some people are only looking at that number.
Right. And and that's a good point. If I could just touch on this, like really super lightweight hubs, which people were going crazy, again, 10 years ago with extremely lightweight hubs with really small bearings. And one of my customers did some tests on those hubs versus his hubs because they were heavier and he used a thicker axle and so forth. And in some of those hubs, when you're going up a hill, the bearings, the thin bearings, because they're so thin, they're only a millimeter thickness of the race, they actually lock
distorting.
up. Yeah, they're twisting so much that they're actually locking up and skidding. So if you're going up a hill, you essentially have a drag brake that you're working against. And sure, they're light. You just shaved some weight off your bike, but you're working against yourself because that's like the worst case scenario. Now you got a drag brake going uphill.
So I think at this point, anyone who's made it this far into the conversation should have an appreciation of just how much goes into not just bearings, but the bike generally to make it function as well as it does, and kind of a sense of the depth of innovation and all the layers of innovation that have to happen at every level, from the steel maker to how it's heat treated to new coatings to how it's assembled and so on, that go into making a product like a 20-pound bike that can go over single track at high speeds under a heavy rider and do so day in, day out for years on end. I hope also that folks get a sense of what you compromise when you push up against the limits of that. Because technology and material science and so on can take you so far in pushing the envelope in terms of performance and weight and strength and so on. But there is a point at which you're compromising something. And so I want to acknowledge how cool it is to hear and detail the innovation that you and your team have done in order to enable the sorts of highly reliable, high performance bicycles that we have today. And then also the transparency on how that process works and the trade-offs and so on, and being able to unpack that with you today has been a lot of fun and hopefully has been informative to some of our listeners here. Is there anything else that you think listeners should know about bearings and how to think about them and what to look for?
Yeah, I mean, obviously, when you're talking about our product line, D15 is the best stuff, but you might not be able to afford it. But we try and engineer, what we learn at the very top end all the way down into the ABEC 3, the blue seal bearings, which is our most popular. You'll pay for the blue seal bearings, retail $10 for a bearing, but it's still a really good bearing because it has LLB seals. It has designed with the larger balls, deeper grooves. So we pass all that technology all the way through the line so that what we learn at the top, we put onto the very entry level. And so it's still a really good, well-designed bearing with all the hallmark points of the high-end stuff. So, and that's what we're trying to do. That's what I spend all my time doing, is making the best thing at all the different levels. We're kind of different because some companies only make bearings at the very high end. Some companies making them at the low, medium end. And so we're unusual that we have this spectrum, and the amount of bearings we have too is just crazy. But anyway, with every single bearing, and we have over 1,200 for just the bicycle industry, my eye's been on every single one to make it different and better than, or for the bicycle application it's made for.
Yeah. And that really shines. It really shines through in just how much passion you have for this as well.
It sounds a bit boring, but I like it. It's fun. It's a good challenge, and I have fun doing it. I love the bicycle industry, obviously, but it's fun doing it.
No, that shines through very clearly and is something that I appreciate the opportunity to share with you today. Thank you very much for coming on.
Thank you so much for having me. It's been fun. This is my favorite part, is talking about this stuff. So I appreciate it.
So that's going to do it for this week's edition of the Gravel Ride podcast. Huge thanks to Randall Jacobs for taking over the reins this week and diving into bearing technology with Matt Harvey. I hope you enjoyed that deep dive into the tech and learning a little bit more about the Enduro brand and Matt's long history in the sport. Additional big thanks goes out to Athletic Greens. I hope you go check out athleticgreens.com/thegravelride to learn more about that product that I wholeheartedly endorse. If you're interested in connecting with me or Randall, I encourage you to join us at the Ridership. That's www.theridership.com. It's a free global cycling community where you can connect with athletes from all over the world and talk about really anything you want. If you're able to support the show, please visit buymeacoffee.com, where ratings and reviews are hugely appreciated. Until next time, here's to finding some dirt under your wheels.